So this is the 21st seminar for structural engineers. If you've not seen all the other 20, they're available on YouTube under my channel, known as Daddy Pig. If you search for Daddy Pig 6354, you will see the videos there. They're split into 3 playlists. And we've got the CPD webinars, all of them in full, and then we've got some extracts which look at the MathCAD for structural engineers. And then there's a couple of videos on the deep thinkers side of things. So please subscribe to the channel and share the show with your friends, and of course hit the like button. This is a trip down memory lane for me, and it was inspired in December as the realization that it's been 25 years since I was awarded a PhD. I was also reminded by a thing called ResearchGate, which keeps sending me statistics on my research papers that they have. So today we're going to be looking at the 4th Industrial Revolution and something called Construction 4.0. However, I've been here before, and I think we've been here before. There's nothing new under the sun. We just give it new names. So I'll be looking at, in particular, my paper called Construction as a Manufacturing Process, and going back to see if anything has changed since 1998. So predicting is very difficult, especially about the future, but the best way to predict the future is to invent it. Now, I didn't actually invent the future, but I was around for when one aspect of what we now consider to be the future, and even the present, was developed, and that is BIM, Building Information Modeling. And that emerged from product modeling. That was all the rage in the 1990s. So we'll look in this seminar as what we were trying to achieve with our research and development activities in the 1990s. Seems such a long time ago now. So we'll look at product modeling, building information modeling, industry foundation classes, and our dreams of interoperability. We'll then visit my 1996 paper on construction as a manufacturing process and provide thoughts relative to that with the 4th Industrial Revolution, what's now known as Construction 4.0. However, we'll finish with a reminder of the information facts of life. So here is the published. This was an updated and extended version published in 1998, published by Elsevier. That, unfortunately, is now behind a paywall, so I now have to pay to look at the research I used to do and the papers I've written, similarly with on the I/E website, and it's behind a paywall. It's cited through a thing called ResearchGate, which is a nice little tool for academics as to exchange information. And this little tool keeps sending me emails and saying they've found another citation. And the citations in December were up to 74. And considering that most papers don't get citations and your average is about 1, this must make my paper pretty much seminal. So looking back, yes, that's what the state of computer graphics was around in 1990. And this was the vision of the future. What we were doing at the time was basking in islands of automation. So you had standalone computers doing analysis, and then another standalone computer doing CAD or drawings, and then other computers doing accounting, data management, and so forth. And these all lived separately. And the vision was that from the 1990s onwards, this sea would fall and those islands would merge into one and would be in a happy land of open interoperability. Didn't quite work out that way. Back in 1994, this was involved in the SimSteel project, which was I was involved with. SimSteel was standing for Computer Integrated Manufacturing for Constructional Steelwork. And what we were trying to do is take the lessons from the manufacturing industry and apply them to the construction industry, in particularly the constructional steelwork sector. And SimSteel developed a strategy for IT exploitation, and it put it at different levels. So the first and most obvious, which is what we were doing in the 90s, localized exploitation. So you take new technology and put it into existing organizations. Then you have internal integration, so that within a company, you can exchange digital information between different parts of that company. Then you go on to business redefinition, because what we had done in the past was replace paper-based systems with computer-based systems. But this gave us the opportunity to start redefining and reorganizing businesses around the new technology. The next stage would have been redesigning the external links and how we relate to other companies and exchange information. The final would be to redefine the industrial sector, so totally altering the way in which the sector operates. Now remember, this was the vision of the early 90s. I think we've achieved several stages of that, except this final one. And I think that's what Construction 4.0 is trying to do. So previous viewers of my seminars may recommend or recognize this particular diagram. We looked at design as a production process. So this is quite common in the manufacturing sector, is to develop what are known as ICOM diagrams. So you have an input, an output, a control, and a mechanism. So applying that to our design process, our input will be the client's requirements, the site constraints, and the assumptions that we need to develop our design. The output, obviously the counts, the sketches and the drawings and the specifications that will be used to build the building. The controls, well, things like national standards and codes of practice, building regulations, and so on. The mechanisms, well, the primary mechanism is you. You are the engineer, you are taking that input to produce the output, but you'll be using some tools along the way. Now that can vary from pencil and paper through to advanced IT systems. And this was the high level page for the activity model for what would have been a STEP data exchange standard, AP 230 for the steelwork. So here are the inputs, here are the outputs, here are the mechanisms, and here are the controls for it. And if you break that down, it's a series of cascading diagrams going into more and more details. And each of these lines will effectively represent an information exchange. The result of the SimSteel project was the publication of the SimSteel integration standards. And version 2 was published around about 2001, 2002 by the Steel Construction Institute. And it was published in 6 parts. And because of that, I went around primarily to the US to teach software engineers to write translators. And these were the software companies involved, looking at design, analysis, details, and fabrication. So I was assisting them with their translator developments. And we got export applications and import applications, and this is the matrix of the two. Coming nearer to time, in 2020, I was looking at a job which was using ETABS. And so one way of testing it is you do an export. And yes, ETABS has a CIS2 export functionality. If you click on the file, export, and under there is CIS2 step file. And you can then import that into other applications, including a Vermal modeler. Here's an example of the Vermal modeler, VRML, the virtual reality modeling language. This was in 2021 where I was doing a peer review. Now, the original engineer was using SAP 2000. I don't have SAP 2000, so I just asked them to send the CIS2 file. And so we can manipulate this in 3D and see the elements needed testing. So what was the interaction between CIS2s and IFCs? Well, CIS2 was looking at the structural domain, Obviously, as structural engineers, we need to interact with architects, mechanical, electrical, and public health engineers, as well as facade engineers. And this is where the IFCs came in, or industry foundation classes. And these were born out of the Industry Alliance for Interoperability, which was primarily headed by Autodesk, but pulled in many other software collaborators. The IAI eventually became the International Alliance for Interoperability, and then Autodesk eventually released Revit based upon this technology. Which brings me to building information modeling. Well, BIM is basically a specialization of product modeling. It's applying the product modeling data techniques to the building sector. And you can look at the life cycle of a building and go around the life cycle and pick out those applications. And the idea was that you would have a common building information model. I'm not quite sure we're really there yet. So this was set out sometime in the late 90s as about the levels of BIM maturity. So level 0, yep, 2D models, standalone, low collaboration, been there, done that. Level 1, we're well on the way with this. You're doing 2D and 3D CAD models and exchanging information based on a common data environment. We're getting towards level 2, and many have implemented level 2, which is collaborating around your 3D model using common file types like IFCs. Level 3 is the next level, and I don't think, and I've not noticed anyone who's actually gone for level 3, which is a common data environment with a common unified BIM model with full data management, and that's the difficult part. There are all sorts of not just technical but legal issues related to that. And we're going from 4D, which now includes the time as well as the 3 dimensions in space, and onto 5D, which includes cost, that dimension that Einstein forgot. And then they've introduced 6D, which is focusing on the full management of the building's life cycle. So you're going from concept and design to construction, operation and use, then potentially demolition and reuse. And this would be quite useful if you want to look at the whole life cycle cost and look at sustainable design. Which brings me quite nicely onto Industry 4.0. Well, this is simply a tag for the 4th Industrial Revolution. And it converges a range of technologies. So you're applying the internet to all sorts of things, ubiquitous connection. So robotics, artificial intelligence, augmented and virtual reality, 3D printing and digital twins, all combined. And this gives us an opportunity to significantly improve the efficiency of the design and construction processes. Now, if we apply that to construction, we move on to Construction 4.0, and that's basically what it is. It's applying the technologies of the 4th industrial age and applying them to construction. And we're moving from a linear to a circular system. This is the idea of more sustainability, and that we look at the whole life cycle of a building, or a building project or a facility. And it provides a construction industry with a decentralized connection between the physical space and the cyberspace via on-demand, seamless and secure connectivity. Consequently, they think the problem is one of big data management and connectivity, or so they think. There's many proponents of Construction 4.0. One of the main ones in New Zealand seems to be HERA. So this might be the vision of the future. We're all going to be replaced by robots. I'm not sure why a robot needs a hard hat, and if he does, I can't see him replacing us anytime soon. But humans might have a slightly different view of it. In fact, they may pick up the attitude of good old Ned Ludd. During the first industrial revolution, the Luddites got together and worked out that, well, if a machine can do the job of 10 men, then surely 9 men would be put out of work. So they smashed the system and smashed the machines along with it. The reality was that not 9 men would be put out of work, but 90 men were employed as the demand for cloth increased quite dramatically during the Industrial Revolution. Now, manufacturing and the origin of manufacturing and mass production, you always look at the automotive sector, and in particular, the development of the Ford Motor Company. And a person called Frederick Taylor was instrumental in the development of the Ford Motor Company and its thinking about mass production. Now, he published a book in 1911 called Scientific Management. And many of the later theories that I discuss in my 1998 paper have their origins and bear a striking similarity to the ideas put in Scientific Management, published over 100 years ago. You see, Frederick Taylor was just as determined as all these modern successors were to build quality and productivity into the manufacturing process. He didn't like inspectors, and he was going to go for the one right way, which guaranteed 0 defects. And Henry Ford claimed that his assembly line built in quality and productivity into the process. Now, some of these worked and some of these didn't, and it would appear that the failure of Taylorism was due to the inappropriate or incomplete application of theories. And now we see many subsequent management theories and manufacturing techniques failing for the same reason, because, inappropriate use of the technology or insufficient use of the technology or the theory. However, it should be pointed out that just as one business theory becomes mainstream, the world moves on to make it obsolete. And I discuss many of these business theories in my 1998 paper. I think you're also misunderstanding the construction industry. So effectively, the construction industry is still at the horseless carriage stage in its development. Each building is unique and made to order by craftsmen. So this was true in the 90s, and it's still true today. As in manufacturing, this craftsmanship is not the result of some dedication to quality. It's merely the source of inefficiency. However, those forcing the construction industry and the professionals in that industry into that automotive mold are misunderstanding the very complex nature of the businesses of construction. This single model view declaring all industries to the same is an oversimplification. And for those who don't know, that is a horseless carriage. They basically took away the horse and added an engine to a regular carriage. And this is a vision of construction as I see it, and I saw it in the 90s and I still see it now. However, solutions from the manufacturing industry cannot simply be added or applied to the problems of the construction industry without those solutions first being re-engineered themselves. Yes, the construction industry has been slow to adapt to technology, and it does remain largely a labor-intensive and a low user of technology. However, this is not because those involved in construction are by nature resistant to change. This does a disservice to those in those industries because they're not Luddites, they're realists. They're not really out to smash the system. They just need to know that the system actually works and is profitable before they adopt it. So construction professionals will adopt new techniques and new technology when it's seen to be beneficial. They will not adopt new technology for the sake of it being new. It's not that the industry performs individual activities in an efficient manner. It's those activities, when put together, are an inefficient way of producing buildings. Now, if you talk to anyone in automotive manufacturing or aerospace manufacturing about how we build buildings and the whole processes and a whole range of people involved, they will say that's nuts. So what's the elephant in the room? Here's a picture of my favorite AI generated picture. So the technological innovations, when you try to apply them to construction, they tend to fail. And the reason they tend to fail is they ignore the most important aspect, as people. We need to bridge that gap between humans and computers. And on the right here, we see the range of activities, the things that computers can do and what humans can do and what they particularly excel at. And so computers are getting better and better at not just processing data, but also generating and manipulating knowledge. And it's getting towards the stage where it's looking like wisdom. However, no matter how sophisticated the electronic system that you're using in practice, your professional's knowledge will remain with you. And if anything, it's going to be enhanced by these systems and by the feedback that you get from these systems. So we need to look at the human factors when you're developing any information and communications technology or any knowledge-based management system, if they're going to be successful in adoption. Coming back to the 90s, product data technology and those in it and the researchers in it often quoted Lewis Carroll, because Lewis Carroll was also known as Charles Dodson, and he was a mathematician and a logician. And if you read the books carefully, Alice in Wonderland and Through the Looking Glass, you will notice he's playing with words. And there's lots of manipulation of words, which is quite clever, completely lost on children, of course. And so I think the PDT technologists were getting it wrong. So I've quoted Humpty Dumpty in my PhD thesis in the conclusions of it. And so Humpty Dumpty says, when I use a word, it means just what I choose it to mean, neither more nor less. Well, the question is, says Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be the master? That's all. Now, many technologists looked at this and said, well, this is all very silly, isn't it? Surely we must be more precise with our language. But if the use of Humpty Dumpty's technique may end up making communication impossible, at least he has clear-sighted enough to know what he's doing. Failures in communication are frequently complicated by an unwillingness to recognize high-handed dealings with a language. And this is a common fault in lots of software and in lots of businesses. Now we come to the information facts of life. An overall point is that if anybody's going to use a specified information system or a format or software, then the willingness of those individuals to use it depends on how much they were involved in developing it or trust those who did. For the many diverse information users at large organizations, one thing is certain. Effective information management must begin by thinking how people use information, not how people use machines. So point one, I've developed here, represented here. Information evolves in many directions, taking on multiple meanings, and this was inspired by the work of others as well. So IT specialists are often drawn to common terms like customer or product, whereas most information doesn't conform to such strict boundaries. It takes an awful lot of effort to say, well, what is an element? What is a member? What is a connection? And so forth. What we were trying to do in the SimSteel project is represent information in the real world into computers and enable it to be exchanged. However, we should look at a human-centered approach to information, and that calls for preserving the rich complexity we want in our information diets. So we know what we mean by product or customer or beam or column and so on, but the computer isn't really that smart. Point two, people don't share information easily, and this seems to be especially true in New Zealand. If knowledge is power, why would you share it? Why on earth would anybody put a whole load of seminars together and post them on YouTube for free? Maybe it's just for the likes, and maybe it's just for the subscriptions. So answers in the chat, please. Assuming different departments, professionals, or line workers will want to use technology to share information is one of the biggest mistakes executives make. However, it's a fundamental assumption made in any plan IT system that if you build it like Kevin Costner, people will use it. Number 3, changing the IT system won't change a company's information culture. The presence of technology in and of itself cannot wholly transform a corporation. So changing a company's information culture requires altering the basic behaviors, attitudes, values, and management expectations, and the incentives that relate to information. So you need to have a reason to share information. You need to be incentivized to share information. Yet in most companies, many managers still believe that once the right technology is in place, the appropriate information sharing behavior will inevitably follow. I think it's more down to behavioral scientists, management scientists, than the systems technologist and the computer scientist or the software developer and so on. If you want to change information use and if you want to integrate systems effectively. So now we come back to my 1998 paper and re-examine what I was saying then. And what you can contrast is, well, what's the difference between the automotive sector and the construction sector? Well, the design and construction of a building differs from the design and production of a car in several ways. One of the most significant difference is the design and construction of a building is a more collaborative process than the design and production of a car. Building design and construction involves multiple stakeholders, such as architects, engineers, contractors, and clients, who work together, hopefully, to ensure that the building meets the client's requirements and is structurally sound. In contrast, the design and production of a car is typically carried out by a single company that has control over the entire process from design to production. Now, it's interesting that Ford went for vertical integration of his manufacturing process, partly so he could control it. It's interesting that Elon Musk is following exactly the same strategy. Complexity. Well, we like to think buildings are more complicated than cars, but actually it's the processes. So the process of designing and building a building is more complicated than the process of designing and building a car. Obviously, buildings have variables such as the site, the environment, and materials used, and that will affect the design and the construction process. Whereas in the production, the design of a car, it's much more standardized and uses far fewer variables. The design and construction of a building is a much longer process than that of a car. The building design can take several years to complete, depending on the size and complexity, whereas a car, the design and production can be out in a few months. And this is where you will see the automotive engineer looking at the building engineer and going, what you're doing is nuts. So I came to the conclusion then, I'll still probably hold to it now, that profitability has little to do with the efficiency of production. Because as soon as one company has improved its productivity, its competitors have moved on to improve theirs. Advances in the technology and global competition are combining to drive profit margins irreversibly downwards in both construction and manufacturing sectors. You see, the wondrous advance of technology that has come along in the last 40 years hasn't improved our productivity, hasn't improved our profitability. It may have improved our productivity, but what we're doing is we're doing a lot more for less money, for less income. And we're expected to do a lot more for less income because your competition is too. Instead of making products, whether it's a car or a building, I think companies should concentrate on making money. I know that's quite radical. So providing the complete service is much more profitable for the new systems integrators and manufacturers. So I was quoting Ford Motor Company, and it's interesting if you want to look at the development of automotive industry and manufacturing, examine the history of the Ford Motor Company. And by that time in 1998, the Ford Motor Company was definitely a post-Fordist company. But it was selling transport. It was selling not just metal boxes, but the complete service of leasing cars as well. So its financial sector, its financial arm of Ford was far more profitable than its manufacturing side. Similarly, buildings can be seen as facilities that will generate income from its servicing for its entire life cycle. So if we want sustainable buildings, we need to look at the whole life cycle cost and how we operate, how we build, how we design, and how we demolish or perhaps reuse. Steel is quite handy for this because each of the components can be taken apart and reused. I acknowledge that computers have done a great deal to speed up the existing processes, but they're not the panacea that some seem to believe. Commercial organizations will always be driven by the market rather than by technology. And too many researchers are misunderstanding the very complex nature of the businesses of construction. So, as I state again, construction professionals will adapt new technology only when it is seen to be beneficial. The question is, which is to be the master? That's all. So the references, and for the 25th anniversary, I've put my PhD onto ResearchGate as well. And Appendix A of that includes the full and extended version of the paper's Construction as a Manufacturing Process. It first came out as a conference paper in 1996 and then published by Elsevier in 1998. So our next presentation is going to be a joint one, something completely different. Again, I've got a guest presentation by Wai on the precast concrete culverts. So join me again. It's getting better than it was. We've gone from 80% non-subscribers viewing to now down to 60% non-subscribers viewing. If we can improve that, we can actually make something of this channel. So please subscribe to the channel if you already not done so.